Good afternoon, ladies and gentlemen, and our judges. Today we would like to present our project in the title of Synthesis of Magnetic Hydrochar from Oil Palm Front Cellulose for Absorption of Heavy Metal Ion Contaminated in the Industrial Wastewater. And for the introduction in this project. In this project, it stems from our observation that there were heavy metal ion contaminated in the river is what we released from local factories. Normally, in the factory, they usually use the activated carbon powder to remove the heavy metal ion in the water, but in some cases of them, the activated carbon is difficult to remove its particle from the river, and then it's the complicated productions of activated carbon. In our group, we think how to replace the activated carbon powder by using another adsorbent by using oil palm front waste. We know that in the oil palm front have many cellulose, and then we think how to change the cellulose to be the adsorbent by using the environmental friendly process. Then we add the magnetite particle into the adsorbent because we think if it have a magnetic property, it can remove easier from the river. Then in our project, the final product, we think we're gonna do the magnetic hydrochar for replace the activated carbon for the industrial wastewater treatment. For the objective in this project, the first is the synthesis of hydrochar from oil palm front cellulose, and the second is to add the magnetic property to hydrochar from oil palm front cellulose, and the third is to study the heavy metal ion absorption of magnetic hydrochar, and for the last one is to study the reusability absorption of magnetic hydrochar. And this is for the methodologies of this project.
We use the cellulose of oil palm front into the table-like autoclave to the hydrothermal carbonization process, and then we got the hydrochar. Next, we use the hydrochar with magnetite into the cold precipitation process with the ferric chloride and iron oxide, and we test the characteristic with the scanning electron microscope and phototransfer infrared spectroscopy, and we test the performance with the centrifuge and atomic absorption. And magnetic hydrochar have the magnetite catch on the surface of the hydrochar, and then I will show you about the characteristic of the magnetic hydrochar.
For the characterizations of hydrochar, so this is the you see in the cellulose, so you have many organic compounds inside the porous of cellulose, and then when it passes the carbonization, the organic compound inside the porous will be cleaned, and then we check out the carbon element in the hydrochar. We think that we found that the carbon element is increasing, and then for the magnetic hydrochar, so we found that have the bond of iron with oxygen. So this is the molecule of magnetite to be found that in the surface of magnetic hydrochar.
And this is the result of magnetic property you can see by this video. And that I was talking at the first, we have a small particle of magnetite catch on the surface of hydrochar. And let's move to the result of our project. Firstly, we have performance for absorbing heavy metal ion in the lab scale heavy metal ion. So we have checking for three intensity as 100 ppm, 500 ppm, and 1000 ppm. And for the 1000 ppm, our magnetic hydrochar can be absorbing heavy metal ion about 68% or above in every heavy metal ion. At the next, we have checking the factor of absorption. So first we have checking the pH value that affect to the magnetic hydrochar. We found that the best pH that is suitable for magnetic hydrochar to absorbing heavy metal ion is pH of 5. And after that, we're checking the equilibrium time. We found that our magnetic hydrochar can be absorbing in the time of 0 to 45 minutes in rapidly, and will start equilibrium absorption in 60 minutes. And after that, we're checking the mixed heavy metal ion that affect to the magnetic hydrochar. So we all mix all of the heavy metal ion in one solution in the ratio 1:1. And we use 1 gram of hydrochar to checking the percent removal. We found that in every heavy metal ion, our magnetic hydrochar can be absorbing more than 60%. And for the magnetic hydrochar is a new absorbent, so we have to checking the mechanism of absorption. So first thing we're checking about the isotherm. We found that our magnetic hydrochar it's linear isotherm. It means that the heavy metal ion will be catching on the surface of magnetic hydrochar only just one layer. And the next we're checking the kinetics of magnetic hydrochar. We found that our kinetic is pseudo second order. It means that the speed of absorption it depends on the absorption rate. And next we're checking about the reusability. So we found that the maximum time that our magnetic hydrochar can be greatly to absorption in 22 times. But in every time that we reuse, it will be decreasing performance about 1.45 plus minus 0.7%. And the next we are also checking in the heavy metal ion in the real wastewater in metal cover industrial in Nakhon Si Thammarat. So we found that our magnetic hydrochar can be absorbing all of the heavy metal ion 100% or above. And this is the conclusion. So this is the maximum number of our magnetic hydrochar in that can absorbing in each heavy metal ion. So lastly we found the factor of magnetic hydrochar absorption. So we found that the best pH value is pH of 5. The absorption type is linear and pseudo second order, and the best equilibrium time is in 60 minutes, and it can be reusable about 22 times. And this is how to use. We take the magnetic hydrochar into the wastewater, keep it to absorption, and get it out by using magnet, so it will not contaminating left in the treatment system. Thank you.